Okay, now on to problem 8, computing reliability with independent events. And I would be happy to give you feedback on this homework problem if you post it in the week 6 discussion boards. Any problem, really. And I don't know why I didn't think of this before. Just anytime you're doing a problem and you get stuck, one thing you can do is just take a picture of it and you can send me a text message with the picture attached. Or you can use any of the other help resources, but you're always welcome to do that. Or you can just, maybe even better is to upload the picture to the discussion forum, because then we can all look at it and comment and say, oh yeah, here's how I did this, or oh, I got stuck on this problem too. So anyways, all right. So we've got a parallel structure of identical components, and we have a system that can succeed if at least one of the components succeeds. So that at least one idea is going to become important. Assume that the components fail independently of each other, and each component has a 0.15 probability of failure. Would it be unusual to observe one component fail? What is the probability that a parallel structure with two identical components will succeed? How many components would be needed in the structure so that the probability that the system will succeed is greater than 0.9999? Well, take a moment to think about that, and then we'll work through it together. So again, according to the definition we're using in the text, it would not be unusual because the probability of one failing is greater than 0.05. So, no. What is the probability that a parallel structure with two identical components will succeed? Well, let's look at the typed solution and just kind of walk through it. So, the probability of two failures, are you surprised that it's 0.15 and 0.15 multiplied together? So the reason that's true is because these are independent events. One failing will not affect the other one failing or not failing. So we take the probability that one fails, multiply by the probability that the second fails, and that's where we get that probability. And since this number is, what is that, 0.0255, 225, that is less than 0.05, so unusual, according to this definition of unusual that we're working with. And how many components would be needed in the structure so the probability is greater than 0.999? So I think that this is going to be an at least problem. So notice that two components isn't enough because I'm not on the right thing, because, did I do that multiplication right? 0.225, yeah. So then, if we think about this, 1 minus 0.0225, that is not 0.9999% or 0.9999 reliability. We need to try at least 3. So let's try at least 3, and an at least probability can always be answered as 1 minus the probability that the probability that the system succeeds, rather, is 1 minus the probability that it does not succeed, because success and failure in this context are mutually exclusive. Mutually exclusive. So that's where we get the probability that the system succeeds is 1 minus 0.015 to the 3. That's if we have where we're guaranteed that no more than 3 will fail. So now 1 minus 0.099663. We're not quite there yet. So let's try 4 components. 1 minus 0.015 to the 4th. And we're still not quite there. And now we are there. So we need 5 components to make the probability that the system will succeed is greater than 0.999. And remember again, we were computing the probability that the system succeeds using a 1 minus argument. And I'm going to stop the video now and pick up on problem 9. And